This problem is based on weight instead of body surface area. Let's take a moment to read the problem. The doctor orders penicillin G potassium 600,000 units as an IV every 4 hours for a child who weighs 20 pounds. The recommended dose range is 100,000 to 400 units per kilogram per day in divided doses every 4 to 6 hours. Directions for reconstitution are: add 1.8 milliliters of sterile diluent to yield 500,000 units per milliliter. The two questions that we are asked is the dose appropriate for the child, and how much should you administer? We're going to deal with the first question. This question is just like the question of whether or not the med is safe. And so we need to calculate the range that the manufacturer has deemed appropriate. So if we look into the problem, we see a range of 100,000 to 400,000 units per kilogram per day. We see that it's per kilogram, so we know that we need to take the child's weight of 20 pounds and convert that over to kilograms. So I take 20 pounds and I divide it by 2.2 pounds per kilogram. That cancels. Typically kilograms is rounded to tenths, and so I do this on my calculator and round, and I have the child's weight is 9.1 kilograms. Now I want to take the manufacturer's recommended dose and multiply it times the weight of this child to get the safe range for this specific patient. So I start with the lower end of the range, which is 100,000 units. We talked about that the first per is the fraction bar, and I have kilograms per day in the denominator. And I want to multiply that times the patient's weight, so I multiply that times 9.1 kilograms, and that allows my kilograms to cancel, and I get an answer of 910,000 units per day. And now I need to repeat with the upper end of the range. So the upper end of the range is 400,000 units per kilogram per day. And I multiply that times the child's weight of 9.1 kilograms. Kilograms cancels. And I get 3,640,000 units per day. Now I want to compare this to what the doctor ordered. So if I look up at the doctor's order is 600,000 units as an IV every 4 hours. So the first thing that I want to note is that if the child's getting this every 4 hours, in a 24-hour day there are 6 doses. And I want to make note of that because down here the range that I calculated is per day, and I need to compare like quantities. So I'm going to take the 600,000 and that's units, and multiply that times 6 doses, and that will give me 3,600,000 units per day. And so what I have done here is taken the per dose amount that the doctor ordered and figured it out as a per day amount. And then what I notice is that 3,600,000 units is in the range. So is the dose appropriate? And we can answer yes, it is. And that's because the order is in the range that we calculated. And we've talked about that above the range is an overdose, below the range may not be therapeutic. Last thing we have to answer is how much should we administer, and we'll do that on the next video.